I'm going to give you some tips for post-lab 38, determination of the structure of a natural product in anise oil. For question number 1, you'll just be reporting the melting point of your product. Question number 2, you have a few things to do. First, you're going to identify your product based on its melting point. There are 3 possible products for this reaction, and the melting points of those 3 possible products are in table 38.3, which is on page 317. Your possible products are a 2, 3, or 4 methoxybenzoic acid. I'm just going to abbreviate that MBA. So you'll just be matching up your melting point with the melting points of these 3 different substances. Also, you're going to confirm your product with the IR of anisine. Anisine is the reactant. You did not take a melting point of the product of this reaction, just the reactant. You're going to draw the structure of anisine. You are going to match up the IR of anisine with that of a reference for anisine. You just want to make sure that it makes sense. And then you'll also be able to confirm your product based on the structure of anisine. Once you have that structure drawn, then that should be another way to verify the identity of the product. Next, you're going to do problem number 1, which is on page 318. This tells you to come up with a systematic name. Systematic name is another way of saying IUPAC. So maybe you can come up with the IUPAC name on your own, but probably what you're going to want to do is use some sort of reference. I really like Wikipedia for nomenclature. It gives a lot of different names there's like a reference bar when you're looking on the Wikipedia page for a molecule. There's like a whole bar of information on the right hand side. It's got a lot of names in there, so you might find the IUPAC name on Wikipedia. It does, your lab textbook suggests using the Merck Index, which is a printed book, which I'm sure you don't have at home. There's a ton of resources online. If Wikipedia doesn't help you out, then the next thing that I would suggest would be using the NIST Chem web book, because that has a lot of info as well. Or just Googling anisine and seeing what you get. You're also going to be looking for its common name, and of course anisine is one of them, so you're looking for another common name, not anisine. Then in problem number 4, you're going to be doing 2A from your textbook, just A, and this is asking you to write a balanced equation for the reaction of anisine, the reaction that you performed. So first you're going to be, I'm going to give you some tips for this. First you're going to be giving the structure of anisine, and you're going to want to write the whole structure out. And it's going to be easier if you write this in a molecular formula, not write it as the line structure. So your textbook has it written as the line structure, and it's got this sort of notation on it, C3H5. It's going to be much easier if you don't use the line structure and instead write that as how many carbons, how many hydrogens, and how many oxygens there are in this molecule. It looks like 6, 7, 8, 9, 10 carbons, 1, 2, 3, 8, 9, 10, 11, 12, and 1 oxygen. I'm counting that really quick, so I'm not sure if that's accurate or not, so I don't want to leave it. But just double count and make sure you've got all of those on there. Put it in molecular formula. Reacting with potassium permanganate, which is KMNO4. It says, assuming that the products are manganese dioxide, which is MnO2, and the potassium salt of acetic acid, that's going to be KCH3CO2. And then it tells you that the reaction mixture is alkaline, which means that you, if you want to, you can add hydroxide ions to the left-hand side of this equation. You could also add hydroxide to the right side if you really felt like it. Basically, what it's saying is you're not going to be able to balance this equation just with those 4 terms. You're going to have to add other molecules to it. OH minus is going to be one thing that you need to add. And also, if you want to add water, that's okay as well if you need to add water. So if you need water on the right-hand side or if you need water on the left-hand side, you can go ahead and add that. Also, remember that you did put water in there. So knowing that you're going to need at least to add hydroxide ion, OH minus, and you maybe are also going to need to put some water in there as well. This is going to be a tricky balancing of an equation because you're not only balancing it, you're also trying to predict what other reactants or what other products might be present. But I know you can do it. And then the last thing you're going to do is problem number 8 from page 319. There are 2 parts to this. The first one is asking you to take the anisine molecule and imagine that you are doing catalytic hydrogenation. So this is going to be a reaction that you learned in Chem 241, and it wants you to draw the structure of the product, which it's telling you is C10H20O. So actually, now that I think about it, this is not just a 241, but also a 242, maybe both of those. Draw the structure of this product. And then in part B, it is saying anisine undergoing a reaction with hydroiodic acid. So that is HiO4. And it's telling you the product of this reaction is C9H9OH. So this is a really interesting one because HiO4 is not a reagent that is in your textbook. But it is a pretty common reagent, even though it's not in your textbook. This type of reaction is a type of oxidative cleavage that works on an alkene. It is not the same, it's not exactly the same as oxidative cleavage of an alkene that you learned in 241. So it's not going to be like what you learned in 241, but just Google that, look it up on the internet, and you will see some examples of how this reagent works, and you'll get to learn a new reaction. And it's a really easy one, so you'll have no problems finding it on the internet and predicting the product of this reaction.